Dear colleagues, good evening and warm welcome to Luxoft LTS webinars. Before we start, a few words about our agenda today and our speaker. In a few minutes, Lukas will start his presentation. His speech will last approximately 1 hour, and then we will have a question and answer section. I see that many of you have already found out how this Q&A box works, but just in case, you have an opportunity to interact with our guest via our Webex client, and there is a section in the bottom at the right side of your screen where you can post a question to our speaker. Lukas will comment and answer after his presentation, and in case of many questions, you can also find him in social media or via his blog. Also, if you'd like to know about our latest news and events, please follow our pages on LinkedIn and Facebook. And now I will let Lukas Ruebbelke to introduce himself, and one more time, thank you all for joining us tonight. Now, Lukas, it is your turn.
Hello, everyone. Can everybody see me? Waving at the camera. I'm presuming yes. We will, until somebody says something different. Nonetheless, I just want to thank you for this opportunity to get together and hang out with, it looks like, almost 100 friends from around the world. So I love very much sharing things that I'm excited about and technology that helps me solve and build things better. And so with that said, I believe if everything is okay, let me just share my screen and we will get started. There we go. Okay, sharing my desktop. I'm presuming that everybody can see it. And so let's go ahead and get started. So we're here to talk about how to build better Angular apps with NgRX. And I think one of the most interesting things about modern Angular is that a lot of my favorite things that I love about Angular right now actually have nothing to do with Angular directly. They're just good technology that actually works really well. So for instance, I'm a huge fan of TypeScript. I think that by having a strongly typed language, it allows us to communicate intent better, not only to the IDE, but to our coworkers, as well as I'm really, really excited about Observables and RxJS. That has fundamentally shifted the way that I think about applications and how we manage state, how we manage flow, and just even code volume. So I love RxJS. And then as well, Redux has been a real kind of a game changer for me as well. When I start to think about looking back, what are the things that really kind of trip me up? And Redux is a really kind of a simplistic, it's stunningly simplistic and it's almost profound that, here's a simple pattern that drastically reduces the complexity in applications. And in this case, we're going to talk specifically around Angular. But I'd like to start with a quote that comes from a paper that Victor Savkin recommended to me called Out of the Tar Pit by Ben Mosley and Peter Marks. And we were talking about immutable data. And he said, hey, look this paper up. It's pretty good. And so as I started to read it, here is kind of this first, right in the beginning, they make this quote. And I was like, yeah, okay, that makes sense. And the biggest problem in development and maintenance of large-scale software systems is complexity. Large systems are hard to understand. Now, I'm presuming that most everyone in this room are software engineers and have worked on, something harder than a hello world. And I think we can agree that, yes, like the larger the program gets, the more complex it gets. And this is why we get paid to do what we do, because it's a skilled activity. But then they went on to define complexity. And I'm not going to read the whole thing, but the point is that they say that the major contributor is handling of state. And from that comes code volume and flow control. So as we try to manage state across our application, we start to have to figure out how to move that state from one place to another, which creates, flow of control problems, as well as code volume to generate or manage that. And so I started to think of, really state and flow control and code volume. And I just realized without discipline, complexity leads to purgatory. And to that, I think if you've ever been in an application where you're like, I don't understand what's going on, this is really hard, I almost feel like Like I'm here on Earth, but I feel like I'm kind of in hell when I'm working on this application. And so let me just give you a couple examples as we're laying the foundation of why things like state management, flow control, and code volume matter and how they kind of get out of hand. And then we'll kind of dial this back into Redux and more specifically NgRX. So what we have here is a simple Angular component with a method called inbound. And it takes a parameter of item, it does some calculations, then returns a new total. And so now the question is, if I call inbound and I pass the same item into it, and I do this 5 times in a row, what am I going to get every single time? Well, the answer is we don't know, because there is hidden state within this method. And so it really depends on what current category is. And so you can see here that I'm instantiating my component and I'm calling it. And each time that I'm calling it, I'm changing current category and I'm getting a different result, even though we have the same parameter. And so now we have to stop and consider, how do we know when we call this method what we're getting? And then let's add in, maybe another bit of logic in here. And so now we've just increased the possible permutations that we can get from calling this method many, many times. And a good example or a good kind of exercise that I use to prove that we as human beings are not very good at mentally calculating possible permutations is take 1 through 4 and think of all the possible number combinations that you can have with 4 digits. Well, it's pretty hard. It's not something that I at least can do off the top of my head. Now imagine a method that you're calling that has, 3 or 4 possible variables that affect the outcome. Now you have to stop and consider, what are the results of calling this method and how do I count for them? Well, a lot of people will say, yes, that's why we have unit tests. And that's wonderful. And I agree that you should have unit tests. But the problem is that we have the luxury of having a before each block, before every test, and kind of clearing the state. Well, we have the equivalent of that in real life, and it's called refresh the browser or restart your computer. What are we doing? We're resetting state into a manageable place that we can expect. And so the point that I want to make here on this particular exercise with this code bit is that as things start to increase in complexity, the harder it is to know what exactly is happening. So let's take another really simple example that I see quite a bit in Angular applications. And this appears, I think, innocent enough. We have an inventory class that has a ledger with a total of 1,200. And then we have 2 components that are having the inventory class or service injected into it. And now both of them have an add method that can permutate, or actually mutate rather, this total property. And so now the question is, what happens, or how does widgets component know about the business requirements that items component has? So let's say on the items component, total should not go over 100. And let's say on the widgets component, total should not go less than 20. But because both of these classes have the ability to mutate this shared state, they are now at the mercy of each other. And so one component can put another component in a bad place because they have shared immutable state. Now, to be clear, I think that shared state is good. I think that mutable state is necessary. So if you have a form, a user has to have the ability to make a change. Like, so there is, I mean, they say, that, oh, well, I'm going immutable. Well, you have to allow for some mutability at some point in your application. The point is, how do you control that and contain it? And more so, how do you eliminate shared mutable state? That, I believe, is really a recipe for disaster. And one more example here is let's look at, and so this is an Angular 1 example. Again, this is something that I've seen before, that let's say we're making an HTTP request, and let's say when this fails, let's go ahead and retry it. So we need to retry this 3 times before we give up. So very common scenario that we're making a call, it's going to fail, and we want to retry it. Well, how do we solve this? Well, unfortunately, the answer is by adding more state and increasing the control flow. And so now what we're having to do is add in a retries count state, then check that. So this is now a concern that's outside of what we're trying to accomplish, and manage state as well as the control flow. Now the question is, and I'm not going to get into this, but this is Jafar Hussain, who worked on Netflix, and where I kind of got this idea is they had a situation where they had to do 2 asynchronous calls and coordinate so that if one fell apart, it needed to retry, and the other one was not allowed to go till the other one succeeded. So now they're trying to coordinate 2 asynchronous calls. And so you can imagine if this is the complexity for one asynchronous call and managing that control flow, like how much more complex would it be to do 2 or more asynchronous calls and manage it? And so Jafar actually made the point. He said that managing like asynchronous calls or multiple asynchronous calls is one of the hardest things that he can think of in programming, and I'm inclined to agree. So now the question is, what do we do? Like at this point, I think if I was trying to sell programming to somebody and I said these are like the really hard things that we tackle, um, not a really warm, fuzzy feeling that we have right now. And I think that we've all kind of been in these places of like our code is complex. We don't understand something's changing in one place and it's messing up something over here. And so before I get into really Redux and NgRX, let's just talk about Angular and Reactive Angular. So fortunately for us, in Angular 2 and above, they introduced some reactive mechanisms to help us effectively manage state, control flow, and reduce code volume. And so the axis of awesome, and I've trademarked that, not really, but how I see it is it consists of one, better change detection, observable support, and the async pipe. So right out of the gates, we are given some tools that allow us to make Angular more reactive, meaning that as state changes over time, that we are able to just respond to that in a very natural way. And so by leveraging observables and Redux via NgRX store and some of the other utilities there that we see, we can significantly reduce complexity in our applications. And this is really, really, really exciting for me. So the first thing is, let's just talk about change detection. If you have done an AngularJS application, you know that one of the kind of the big tricky things was that sometimes change detection got out of hand using the typical scope digest cycle. In Angular 2, they introduced Zone.js, and essentially what they've done is monkey patched all of the browser synchronous calls. And so what it does is it's kind of patching or hooking into all of the asynchronous native calls. So pretty much everything that's in the DOM that's happening, that Zone.js is kind of hooking into that and watching it. And when something happens, then it's able to intelligently detect that change and then respond accordingly. And so this is why I have this monkey superhero here. It's kind of they've monkey patched it, and it turned out to be pretty awesome. And so under the hood, what's happening is that they're looking at a component and they're creating this change detection class kind of behind the scenes. And what it is this optimized class that keeps track of the current state in the previous state. And when something happens, then Zone.js will go through and say, has this thing changed? And then it will update. And so it's very, very intelligent, very, very smart, and was written by people much, much smarter than myself. Tobias Bosch being a huge um, contributor to kind of just the Angular renderer and Zone.js. And as developers, we do not have to do anything for this to work. It just kind of happens behind the scenes. And the net result is that our application is 3 to 10 times faster, which is really, really important. Also, with change detection strategy is that we can control how Angular will respond when it detects changes. So by default, Angular detects all changes and responds on all nodes. So if something happens in one part of the app, Angular is just going to detect it and respond on all the nodes. But we can set change detection strategy to on push, meaning that Angular will only check for an initial change, and then it is pretty much hands off. So we're essentially turning off change detection for a component branch in our application, which has some serious performance implications because one of the most expensive things that we're doing in an application is no longer happening. So kind of how this works is traditional or just by default, change detection is if something happens, then all of the nodes fire up. And this is totally fine. It's still, again, 3 to 10 times more performant. But what you can do is you can turn on push change detection to say that the nodes that are not read, that we're going to do it one time, and then we're just going to turn it off. What this does is this allows for a node to be populated by an observable. So what you can do is you can actually then just pass an observable in and let the observable do essentially or broadcasting new state. And so we'll talk about that a bit more with the observable stream. But what's happening is now because observables have their own kind of event system baked into it, we can free up Angular to not have to worry about that. And then when it changes, then we can basically fire it back up and turn that node on. Now, one thing that I want to point out here is that when you set a node or a component to on push, that Angular is basically turned off. And so if something happens, the change detection rather, if something happens and you need to actually mutate the state, that, for instance, maybe the templates will not update because the change detection is not on. And so what you have to do in this case is in your subscribe block, you simply need to inject the change detector ref and then just call detect changes. And so this is just, it's a lot lighter than, there's a smaller thing you need to do, but it's a lot better than having change detection turned on for an entire tree. So again, people have done some benchmarks on this and it's really, really fast. Now, the last one is the async pipe. And what this allows us to do is bind directly to observables, which is super awesome, or it allows us to bind to it in our templates. So we can actually pass an observable or a promise, if you want, into our template, and the async pipe will automatically unwrap it for us, but also it will unsubscribe from the observable when the DOM element is removed. So let's see what this looks like here. Just in the code is that we have an items observable. So I'm using this $sign to indicate this is an observable stream. So this is just a kind of a common convention that when you're dealing with an observable and it's an observable stream, you just put a $sign at the end of it to simply say this is something that has been wrapped in an observable. And then now by putting in the async pipe, that within this app items list component, it's not getting the observable, it's actually getting the underlying value. So it's actually getting the items collection, which is really, really handy. Now, I want to do a quick detour, and I wasn't for sure where to put this, but this is just, I think it's a handy piece of, or rather a handy topic to discuss as we're kind of talking about how to build better reactive, Angulars. And this is immutable operations. And so we're just think of this as just like an interlude, is a bonus, a couple slides. This is actually free of charge, not going to cost you anything. I'm kidding, of course, but let's just take a moment and talk about immutable operations. And so it's very common. And so this is when you're doing something to just by default, just use a mutable operation. I didn't even really start thinking about immutability until I got into Redux. And so what you can see here is that, oh, I want to create a widget. So what I'm going to do is I'm just going to push it into this state collection. And so a lot of times it's like, well, how do you add something to a collection? Well, you push it in. Well, the problem is that you're actually mutating that array. Now, let's look at another one. And for instance, how do you actually update a widget? And so how I would do this previously is I would loop through and I would find a widget that I wanted to update, and I would then chop it out and put in the new one. And again, still mutable because I'm still mutating my original collection. And one more example here is, well, what if I wanted to delete something? Well, same thing is I'd basically loop through, find the thing that I was looking for, and I would just chop it out. But again, it is mutable. So I want to show you just a few quick ways to kind of work around this. And now that I've kind of seen it, I don't really think about it too much more. So in other words, going from mutable operations to immutable operations is really almost zero effort. So one of the first things that's helpful is using the object.freeze method. So I'll use this when I'm testing and I want to just ensure that I'm doing something immutable, is that it essentially makes an object immutable. So it basically is freezing it. And then if you try to change it, then it's going to throw an error and say like, hey, like you can't change this because it is essentially frozen. So this is just a handy native JavaScript thing, object.freeze, really, really handy. And so let's talk about some immutable versions of the push, that slice, and that we use to update and delete some items. So the first one is to use, instead of push, use concat. And so what concat does is it actually is used to merge two or more arrays, but you'll notice this is according to the MDN. It does not change the existing arrays, but instead returns a new array. And so that's really key here. Also, you notice the top example, I'm actually using some shorthand syntax with the spread operator to actually say, take the existing state, the payload, and we're just going to return a new array this way. So this is a shorthand way to do this. This is actually what I prefer, but it's the same thing, similar to what's happening underneath, is we're just using concat. Another example is that when you need to update an example or update an item in your collection, you can use map. And so this also, if you go look in the MDN, it creates a new array. So instead of modifying an array, just look for something that creates something new. And it basically loops over the collection and returns a new array with the method that you've passed in being operated on every element in the array. Now, kind of as a bonus to this, using object.assign, it's used to copy values of all enumerable properties. So it's basically shallow, but it allows you to do a clone on an object. Now, I've had good luck with this. If you're doing like a deeply nested object, or you're using inheritance, you may need to use something like Immutable.js or Ramda. But for most cases, because I try to keep my objects shallow, that object.assign has worked just fine. And last but not least, that when you need to basically remove something, filter does a really nice job. So it essentially creates, again, following the documentation, a new array with all elements that pass the test implemented by the provided function. So again, we're not deleting something, we're not mutating the array, it's just going through and just returning a new array. So these are, when you look to the documentation, the kind of verbiage that you want to key on is like, does it create a new array, return a new array, create a new object by combining other objects, etc. And so that is kind of the foundation that I wanted to lay for Redux and NgRX, is one that, well, let me say this, that with AngularJS, you can definitely use Redux and NgRX, or rather NgRedux, and it works really, really well. And I recommend, if you're using AngularJS, like by all means do that. But because in Angular 2 and above, we have these reactive mechanisms such as the async pipe, observable support, change detection, etc., is just even better. And so I wanted to just highlight some of those things real quick. So with that said, on to the main event. Let's talk about Redux. And the reason why I said this is a Redux primer is because NgRX, which is what we're really getting to, is inspired by Redux. It's kind of shaped like Redux, but because it has observables, I believe that it's even better. But so let's just talk about the shape of Redux and we'll go from there. So before I go any further, there is some required viewing. I recommend that everybody go and check out this week the Getting Started with Redux by Dan Abramoff. And so this is on Egghead.io. It's completely free. It was exceptionally valued to me. I've watched it a couple of times. Rob Wormalt, who created the first version of NgRX, this is how he did it, is he actually watched this over the weekend, and he liked it so much that he created NgRX. And so I really enjoy the series. It's very valuable. Documentation, as read by the author, is really cool. Dan wrote Redux, and he's just a really nice, gracious fellow, and I have a ton of respect for everything that he's doing with the community, and just his openness to share, and just he's incredibly smart, but he's very humble in the meantime. And so one thing I would like to point out as well is that Redux is a library. It was created for React, but more importantly, it is a pattern. And so you'll actually see Redux imported over into other languages. And so when going forward, when I talk about Redux, it's little r as in Redux, the pattern, and not the actual library that you would use with React. And so Redux is based on a couple, or really kind of three main points. And the first one is that all your state is in a single immutable state tree. State flows down and events flow up. Now, what this means is that because everything is in a single immutable state tree with clear directions on how to interact with that, we no longer have to manage parts of state in controllers and services. And so kind of prior to this, what would happen is I might have a user service, and I would now have to ask myself, do I want it to be stateful or not? Do I store users in the service? What happens if I need to update it from another component? How do I coordinate that? But then what if I have like a portfolio service? Do I manage state in there? And so now you have these services that, or models that not only are responsible for fetching the data from the remote service, but now managing the state. But it actually can be spread across multiple services. And in some cases, application state is stored into controllers. And this is what we're trying to break away from. And so what Rob Wormald did is he watched the series and he sat down and he said, I really like this a lot. But what I'm going to do, because I also like observables, I'm going to take Angular, RxJS, and Redux, and I'm going to combine them, and I'm going to create NgRX. So this is really NG for Angular, RX for reactive extensions, and the big one there is the NgRX store. Now, what I recommend as well, that when this webinar is over, go check out this example right here. So this is, they've added some new things. I had the opportunity to get back and reacquaint myself with it a couple weeks ago, maybe 4 or 5 weeks ago, and they've actually made some even better improvements that I've integrated. I really, really like. So this is kind of the canonical NgRX best practices application. Now, with that said, I have created a sample application that I use when I talk about NgRX, and it's at github.com, onehungrymind/dashing-angular. And so this is an NgRX application that I created. So it's a master detail view that is using essentially the best practices of the NgRX sample application. So let me just show you real quick what this looks like. So I'll just tab out of here, and what you have is kind of this sample application where it's called dashing because it is a dashboard. More so, kind of the idea was to be more of like a financial, like data style dashboard. But then we have kind of a master detail view here, which I believe is the single most fundamental important interface when you're creating applications, because especially with line of business applications, everything is really essentially a master detail view interface. I mean, when you talk about the to-do list, what is it? Is that you have a list of to-dos, or in this case, portfolios, and you can then select it. You can see details about it. You can create new items within it, but it is a way to see a collection and then manage the items in that collection. And then over here, we have stocks. And so this is just a variation of this that you can see the stocks. based on the symbol. So fairly straightforward, but this is done under the hood using NgRX. And so we will kind of explore this as we go through more of this webinar. So back to the slides. Let's keep going on. And so the fundamental piece that really for me that changed is realizing that state is in a single state tree, that all your state flows into a single place. And then what happens is you have essentially this application store that has everything that just revolves around it. So just as the sun is kind of the center of our solar system, the application store is the center of your application itself because it holds the state for everything. And then components, templates, services, they all pull the state off of the store. Well, the question is, well, how does that happen? And so in this case, state flows down. So it flows from the store to the service, to the component class, to the template, as well as so state flows down. So for instance, we have it in the store, maybe it goes through a service, into our component class, into a template. Then if we go with state flowing down, then the next piece is that events flow up. So just coming from the other side, it goes from the template, component class, service, and store. It seems like I've lost my arrows on my slide, but I'm not going to worry about that. So just remember that state flows down, events flow up. So we'll see what that looks like in just a moment. And so how do we actually interact with our state? So think of state as your database, or your store is your database for the application. And eventually you need to interact with the store and you just say, hey, like I need to make some changes here. And so what sits in front of the store is a reducer. And what the reducer does is it'll listen for an action. In this case, so you can see here like action types, select, clear, etc. And based on the action, it will perform an immutable operation that will take the existing state and just replace it with some new data or a new state. So it's always immutable, it's always pure, and it listens for a particular action that's coming in. It then makes the appropriate operation, puts that into the store, and then it flows back down. Now, what's interesting about this is that think of reducers is kind of like your tables in the database. So, for instance, if I have, let's say, a portfolios feature and a stocks feature, is that I will create a reducer for each one of those features that they then can get combined into a master reducer. So generally what I do is I will break out and create a reducer for each kind of entity within my application domain and then combine them. But what this allows us to do is you can see here that let me just go over here, is that we're taking all of our reducers and combining them into a single reducer that we are just creating, and exporting is kind of this master reducer. And so what you can do is you can have a bunch of tiny reducers that you then combine into a single reducer, which you then provide to your application. And so this is, once we have it, then we say, okay, now store, here are the reducers for all of the models that we have. And we'll talk about kind of the rest of the pieces here in just a moment, but let's talk about how state flows down. So we're going from store to service to component class to template. And what does that look like? Well, first and foremost is it starts with the store. And so what I like to do when I'm working in an application, especially now with TypeScript and I use WebStorm, that I can kind of click in and say like, well, what's actually happening under the hood? And so this is what the store looks like. And I think it's maybe not super intuitive what's going on, but what I want to draw your attention to is two methods here. And this is the primary way in which we interact with our store is via select and dispatch. And so now what we have is in this portfolios component is we want to get the portfolios. And so what we're saying is store.select. So we're passing it in. And within our reducers, we're saying get portfolio. So this is a selector. And so it's getting the portfolios and returning it as an observable. And for the current portfolio, as you can imagine, we're saying store.select. So again, using this kind of, if your store is the database and your reducers are the tables, then we are allowed to essentially select or query our reducer and get the stuff off of it that we need, or the store rather. And so in this case, store.select, and then we're saying reducers get selected portfolio. So we're passing in the selector to say, get me the selected portfolio. Now you'll notice here that on ng on init, we are dispatching a new action. So what we're saying is when this component loads, what we want to do is the store.dispatch, and we want to dispatch a new action called load action. And so then what happens is that gets dispatched and we're able to pick that up and then essentially load in our portfolios. Now you'll notice as well down here that, well, what happens when somebody selects a portfolio? Well, we're dispatching, we're saying here's a new action, select action, and we're passing in the portfolio as the payload. And so just to kind of walk through this, again, I've mentioned this, is that we use store.select to essentially pull the state off of our store. So remember, state flows down. And then once we have that state, then we can consume it with an async pipe. And so what I want to point out here, and I'll call this out multiple times in this presentation, is that we are going to, or rather you'll see a real lack of code or a very concise amount of code to move something from point A to point B. In this case, within our component, we're saying, give me the portfolios, and then I'm just going to pass it into my portfolio list class via an async pipe, and then it's unwrapped and it's ready to go. Now, let's see with events flow up. Let's see what this looks like. So I'm going to walk through these slides, and then I'll actually show you in the code, and we'll see what this looks like in the actual project itself. So in this case now, events flow up from the bottom up. Now it's template, component class, service, then store. Well, how does this work? If we go to, again, back to our portfolio component, that let's say you select a component, you want to set it as the current portfolio, well, you dispatch an action for that. Well, what happens if you want to create a portfolio? Well, there's an action for that, and you send in the portfolio you want to create. Or if you want to update a portfolio, well, there's an action for that. Now you'll notice here, if you go down to the bottom, same thing. I want to delete a portfolio. Well, then what do? Well, you're simply delegating this back up the tree or back up the chain to say, hey, this thing happened, but I want to put it or make it available to my reducer for it to actually happen. And so one of the problems that we had in AngularJS is that controllers tended to become very, very large with a lot of business logic. And the real responsibility of a controller is one, to consume just enough data to satisfy the view, and when a user interacts with the view or the template, to capture that action and pass it off to a service for handling. And so what you want is your controllers, or in this case, your components, to be as thin as possible. This is very, very important, that you want to delegate as much of the business logic into your services so that they can be tested and reused. And you'll notice here that really the only bit of logic that I have in this particular slide is simply right here. And this is just saying that if it has an ID, then go ahead and update it. If not, then go ahead and create it. So I've reduced this bit of code or this component code to just really consuming data, piping it into the template, or capturing an event and handing it off to something up the stream. In fact, it doesn't even know. It just knows that when I dispatch it from the store, it's going to be taken care of. Now, speaking of actions and dispatching them, the interface for this is really quite simple, is that every action has a type, and then optionally you will have a payload. And so sometimes you just need to say, hey, do this thing, and it's just kind of a broadcast message. And other times you need to send something down the wire. So from here, that we're creating an action types object that we're going to export. But more importantly, if you look at load action, that it simply has a type on it, whereas the load action success has a type, but it also takes a payload. So sometimes, again, you just need to actually broadcast the action without a payload. So it's just like, here's this trigger to do something. And other times you'll need to just send it or send something along the way. And that's where the payload comes in. So actions are very simple, type and payload. And then what happens is that the reducer will then listen for this action. So it's looking for, in this case, action type select. And then based on that, it's going to do something with it. And so in this case it's saying that we're going to select the action and we're just going to return a new object. And the one thing that we're going to change here is that we're not messing with the IDs or entities, but on the portfolio, we're just going to say action.payload.id. And if we wanted to clear it, and because there's a use case for this possibly, we're just setting it to null. So both times, though, again, we are returning essentially a brand new object, and we're just updating the properties that we want to that we need to change. And so in this case, it's just selected portfolio ID. So very simple example, but you can see here that essentially from the component, we dispatch the action, and then the reducer picks it up and does something for it. So this is a graph that my friend Gerard Sands did that I like quite a bit. It's, I think, kind of flip-flopped a little bit, but you can see kind of how this works is that starting at the bottom with the view here is that it dispatches an action, which goes into the reducers and for processing, and then it essentially updates the store, which, because the view is then subscribed to that via an observable, that it's automatically updated. And so let's just take a quick second. And before we go any further, let's just hop into this code and let me just walk through this. So in our portfolio component, you'll notice here, again, portfolios and current portfolio. And in our constructor that we are just calling select on the store, and we're getting them. So we're getting the portfolios and the selected portfolio. So this is really quite simple. Like, this is all we need to do to populate our portfolio stream and our current portfolio stream. And actually, let me go and pull this up in the template. You notice here, because of the async pipe, I'm just taking and I'm just passing these directly into the list component and the details component. And so I'm not going to talk about container presentational components too much in here, but the one thing to point out is that in here, I'm actually on the spec here, hold on. So if we go into the list, that it's getting this collection, and this is truly just a presentational or a dumb component that there's no logic in here. It's just getting the list and it's just saying, okay, I'm going to render it. And so this makes for some very lightweight components that I would say are not even testable per se, because there's really no logic in them. We're just passing in a collection and letting it render. And so now let's go down here and you can see that we're just dispatching actions when somebody either sets the current portfolio, creates updates, or deletes. And so you'll notice here that I have outputs on these components. So select, delete, save. And then all we're doing is we're just capturing that event and we're dispatching it dispatching it up for our reducer. And so what I think is funny about this, or interesting, is that the only real logic in this entire component, and this is a container component, so it's actually controlling a few other components, the list and the details component, comes down to the save portfolio method that we're simply saying if it has an ID, then go ahead and update it. If not, create it. So this is kind of the conundrum that I ran into with do I create a new form to create an item, or can they share a form? So when you're creating or updating, oftentimes the form is exactly the same. It's just one is updating and one is creating. And so that's kind of how I solve that. Is I'm just saying if it has an ID, then obviously exist, go ahead and update it. If not, then create it. And so this is a very simple component, or the complexity of it has become really, well, it's significantly reduced because all it's doing is pulling in, consuming data, and then delegating back up to the reducer via the actions. Now, I have two kind of other concepts that I want to talk about, and then we'll get into some Q&A. But invariably, um, the next question that kind of comes up is, once you kind of wrap your mind around this, is what happens when you have two items or two entities that are actually related. So let's say you have like users and items. Do you put that into like the same reducer, or do you separate them, or how does that work? Well, I think that the way to handle this is, one, keep your entities in their separate reducers, and then from there, then essentially compute or derive a computed data set off of the state of both of them. And so I'm going to show you two ways how to do this. There's two ways to do this, and one is a little bit simpler. There may be a good reason to use this, and then I'll show you the example or the technique that is in the kind of the NgRX sample application. So because we're using observables, one way to solve this is, so let's say you have users and items, is to use observable.combine_latest. And so what this does is that it takes two observables, and when either one of them changes, then it allows us to create or computes a new observable that returns a value that is essentially the product of whatever combination logic that you've put into observable.combine_latest. So you can just think of that when one or the other changes, then it's emitting a new value down the stream to be consumed. So we can use observable.combine_latest to take multiple streams and compute a new data stream. So when one changes, the other one is produced, a new one is produced. And the beauty of this is that, and this is where I may use this over the next technique I'm going to show you, is we can leverage all of the power of RxJS in this process, which is really, really cool because RxJS has dozens and dozens, I mean, I think it's over 100 operators that you can do some really powerful things. And so now, if you look here, that to just follow this through, we have our user data, which has name, items, and widgets. So items is a collection of items. Widgets is a collection of widget objects. And then within our home service is that we are essentially grabbing these as individual streams. So we're saying we're going to go ahead and load the users, the items, and the widgets. And now this is where the magic happens. And so using observable.combine_latest, that we can take every one of these streams. And so now we have essentially a user stream, item streams, and widget stream. And then this last parameter is essentially our logic to how do we want to handle this. And so we're going to map over the users and create a new object, or kind of this meta object or combined object that has the name of the user, but then it has items. So we're just saying, give us all of the items that is available for this user. And we're doing the same thing for widgets. So widgets.filter, and we're just filtering out all of the widgets that do not belong to the user. And so now, using combine_latest, that when either one of these streams change, is that a new value is emitted to the component. And so now we're saying create a data stream. So this is kind of the combined data that we can then grab off of this .homeservice.data. And then from there, we can just using the async pipe, we can loop over it and display it. So this is how I solved this problem initially by hand, is just using observable.combine latest. It works really, really well. But there is another technique that you can use using selectors from React Reselect. And so what this does is it essentially allows us to create these small, lightweight selectors. So again, following this database analogy, is if a reducer is a table, then selectors are really the queries that we can use to compute derived data, just like observables, is that they're not recomputed until one of the arguments changed. And what's interesting is that you can compose them to be used as input to other selectors. So you can start with a bunch of simple selectors and then pass those into a larger selector to do some really interesting things. So in a very simple form, is that we have, if you look at get portfolio IDs here, is that we're just grabbing the state and then we're passing in the IDs off of the portfolios. And portfolio entities, we're just passing in the entities. So what's happening is, in this example, we have portfolios where we're separating them out by IDs and entities. And so you can get just the IDs, or you can get the entities, or you can get the selected portfolio by, again, passing in the state and then pulling off the get selected. So now we're passing in this other selector here. The other thing is with get portfolios is that if you want to get them all, then we get the entities, the IDs, and then from here we are combining them by basically zipping them back up together. And then from here, let me just carry this through one more time. So get selected, as you can see here how we separated those out. Well, what this looks like is we're just grabbing the entities and we're just passing in the selected ID. So essentially what you're doing is an object map to get that. And then one more for computed data is, you'll notice that in the sample application, you're able to actually grab, and when you select an item, so hopping over here, if we go here, when you select this, it's going to return the stocks that match the symbol. So back to here is that we just create a selector for this. So very easy. We just simply say, if you have a symbol, so if not, then just return the stocks. But if there is a symbol, then just filter through and return the stocks that match the symbol code. And so this is an example of computed data. But now this is really, really easy to test as well. So one of the benefits that I haven't mentioned, or I haven't talked a lot about, is by breaking these things into small composable pieces, that we now have really easy to test bits of code, that we're removing all of the hidden state and all these things, is that everything is pure functional with kind of a clear contract to the world. And so for my last and kind of final technique that I want to talk about, and then we'll get into Q&A, is let's talk about async operations, because this is kind of the second thing that I kind of really confused me when I was looking at Redux. Is the first thing is, well, what do I do if I have multiple entities? How do I come up with like computed data? How do you approach that? And then the other piece is, well, what happens if I have to do something that actually I need to update the server and there's some kind of side effect? How do I handle that? And so the next thing is, well, how do you handle async operations in a Redux or NgRX style application? Well, the easiest way to do this is to simply put a service that sits in front of the store. So I would say load items, and then what I would do is I would actually go and get the items, and then once I have it, then because we're dealing with observables, is I would just map the result to an action item, and then I would just dispatch it. And so this was kind of a really handy way to kind of intercept an async operation. Once it completed, then I just put it in the store. And so this is a very kind of a simple, low-tech way to do this. But there is, in some cases, this may be sufficient, by the way, but there is something that was introduced recently into NgRX called effects, and I like this quite a bit. And so just think of it as middleware to handle asynchronous operations, effects being side effects. And what it does is it just captures an initial event, performs some asynchronous operation, and then fires off a completion event for the reducer handle. Like, wait a second. That sounds almost exactly like what I did in the previous example. The advantage of this is that because everything is an observable stream, we have all the power of RxJS at our disposal to do complex data manipulation. But also, what this allows us to do is separate the asynchronous call to the server completely out and just basically handle the control flow within the effects. And so let's see kind of what this looks like here. So the first thing that we need to do is, this is just right out of the gates, is that we are importing our actions and our effects. So this is a portfolio effects. And then from here, you'll notice that within our action, so this is an effects actions, is that it has of type. So again, I like to click through and I like to see what's happening under the hood. Is we're importing actions, and so that's kind of the most important thing, and it has this of type property. And so what it essentially an effect sequence looks like now is that you basically define an effect. So we're using metadata here, and we're saying this is an effect, and we're listening on our actions for the load action type. And then from there, we're doing our asynchronous operation. So this is switch map. We're saying, okay, once this thing comes in, do this. And then when that is returned, go ahead and essentially dispatch. So this will dispatch this for us, a load action success, and pass that in. Now, we'll see this in the code in just a moment, but what this allows us to do is now free up our portfolio service to focus entirely on just handling the server-side call or the asynchronous data. So here, we're just grabbing this and we're saying go and return whatever this is, which then goes into our effect, and then it gets passed up the stream. So now you can see here that when we load action success, and this is a little bit more of a complex reducer function, but we're saying when it comes in, let's go ahead and split these out so into IDs and entities. And then we're just going to return a new object with the new IDs, the new entities, and we're going to leave the selected portfolio ID the same. But you could, based on your use case, essentially say, I want to actually clear it out. So whatever you need to do in there, depending on your case. And then what you do is, now that you have your effect, you need to just wire this up. And so what you'll do is, one, provide the store, and then you will call the effects module, and you'll say .run, and it will basically run the effects that you pass in. So now what it's doing is it's kind of like sitting on top of everything, capturing all the effects and intercepting them before they get to the reducer. And so this is why you're saying, hey, run these effects and make known, or basically make a note of what's happening, because when we start firing these off, you need to be able to capture them before they get to the reducer. So let me show you this in code just real quick. So hopping into WebStorm, you'll notice here that store, dispatch, load action. And then if we go into our effects here, that we're listening for the load action, and we are then calling switch map. We're saying, okay, take this and actually now switch to this new stream that is returned by calling portfolio service. And when it's done, then just return this load action success. Now, same thing here. We want to create. It's doing the same thing. So you'll start to know that this starts to become a bit conventional, which is, I think, a good thing. Same thing, captures create, grabs the payload, then we call the portfolio service to create or delete, whatever. But you'll notice here that at the end of this, I keep calling the load action. So in this case, I've opted to, just as a design decision, is when we make a change at the database, let's go ahead and just refresh and rehydrate the data. So this is maybe something you want to do or not, but the point is I can now control this. And what I think is really neat is if we go to the portfolio service, that here you'll notice that this portfolio service is doing one thing, and that's calling the server and returning the results. And so I'm not having to manage state within the service. I'm handling the control flow within the effects, and within the reducer, you notice at the bottom, I have my selectors that allows me to essentially get IDs, selected IDs, and then, and this is, you'll see this in the sample app as well, that what they do is they actually kind of create these master selectors up here that allows you to kind of get everything. But these are still very, very tiny selectors or pieces of code that every single thing here does one tiny, very specific thing. And so if you look at the component here, in this case, the list is just a dumb component. But if you look here, very, very, very tiny pieces of code. And so this is like the big punchline that I want to get across is because you have state in a single place and because state flows down here, it's very easy to consume, put into your application. So you can see here, we're just piping it right into our component via an async pipe. And when something happens with our component, we're just delegating it back up the chain. And so let me see here, like if we go to stocks, let's see what this one looks like. Again, very, very simple. It's not really doing too much. Very small composable pieces of code. And so this is, again, you'll start to notice things are becoming small and a lot easier to reason with. And I believe that is everything that I wanted to cover. So with that said, first and foremost, I love you. I love all of you. Thanks for sitting in and listening to this. Be sure to check out the sample app. One, I'll try to do some Q&A, and if I don't get to it, you can catch me on Twitter at Simpleton. You can also catch me at, I'll just show you real quick. I blog quite a bit at onehungrybind.com. And so you are welcome to kind of check me out there. I was just actually at NgConf. I'm going to be posting my presentation there, as well as some new stuff about effects and selectors. But this is kind of how you find me if we don't get to your questions in the Q&A. But that is how you will find me. So, I do like to sleep. I like to eat, but I try to be as available and as helpful as I possibly can. And so on that note, thank you so much for hanging out with me for the last hour. And let's hop into some Q&A for the next 15, 20 minutes and just see what everybody thought and try to answer some questions. All right, looking for the, see if I can find the chat here. And 1 second. I know that there are questions somewhere. If you bear with me, this is WebEx is. If you think Redux is hard, try using WebEx. That's blows my mind. All right. Okay. Let's see here. So I'm just gonna go down. Okay, so a couple things. I'm just going to start at the top, and I'm just going to work down. So, the webinar will be posted, obviously, but the sample app is on GitHub, onehungrymind.com. I can also post the slides if everybody would like. I don't have any really reservations for doing that. I suppose it would just if Lexosoft was okay with that, then I'd be happy to do that. So going down here, so the question by Arameus, and if I say this wrong, I apologize. What if switch map operator in some effect will encounter an error? How is that handled usually? So what you'll want to do in this case is what I more than likely would do, because it depends on where the error happens, but generally what I would try to do is try to capture errors as close to the place that they happen. So let's say we made a call and like this, for instance, had an error, or rather you're trying to create something. Well, what I would try to do in that case is I would try to capture the error there, and then you could either try to recover or just let it move on through. But what you would do is then need to put in some error handling from that. So using observable dot catch, you would catch the error, and then using observable dot throw, you would figure out how to do that. And what I would do in here is I would actually use dot catch, and if something went wrong, then I would actually dispatch like a different action, which you can actually see that in the NgRX sample app. And so, it might be something like, load action error to capture that. So Andrea, I believe, is asked, how would you prefer managing forms? So interesting question. Let me just actually show you how I do this in NgRX, and then we can expand upon this. So you'll notice that in the portfolio detail component that this is a form. And so the question is like, okay, obviously it's a form and we are going to need to mutate this. But how do we actually do a mutable operation and allow the user to mutate the data while not breaking, this Redux paradigm? And so how I handle that is I capture when we set the selected portfolio, is that I isolate. What you want to do is you want to isolate the mutation to just that component. So you'll notice here on the input is I'm saying when we set the portfolio, let's go ahead and using object.assign, just create a copy of it. And now in our template that we're binding to current portfolio. So that's instead of mutating the portfolio object directly, what we're doing is just mutating essentially a copy. What that allows us to do, because if you were not creating a copy, that the minute you started to change the form or the object you passed in, is it would mutate up the stream. And so if anything else was bound to it, well, you're going to see that immediately, which that itself is not great. But the better question is, what happens if you make a change and you want to undo it? Well, how do you do that? You can't, because you've already essentially mutated this data. There's, unless you have a previous reference to it, you can't back it out. You've mutated it. That's one of the, I think, things that comes with binding. And so now, in this case, by creating a copy of our form, or rather our portfolio component, that we can then do whatever we want on it. And then when we're ready to mutate it, well, what we do is we simply just emit this back up. But if we cancel, then we just get rid of it. So that's the first thing, is when you're dealing with forms, is you want to isolate the mutation to the component that has the form. And this is really the easiest way to do that, is create a setter for the input, create a copy, work on the copy, and then when you're ready to update it, then you just emit it back up to the container component. Or if you want to cancel it, then you can just throw that away, and no harm, no foul. It just says we're done with this copy. We're not going to do anything, and nothing has changed. Now, the next question here is, well, how about autocomplete? So autocomplete is, I'm presuming you mean like type ahead, is where you start to type and you actually get some examples of, or based on what you're typing, that you get some suggestions to help you autocomplete. And so this is actually kind of a canonical RxJS kind of example. And you can do this without, in this case, Redux or NgRX at all, that you can contain this entirely within an observable stream. So in the case of autocomplete, is I would simply bind to the input of the form element as you're typing, and because you can actually do on value changes, and then from there switch map, and then just provide suggestions. And so probably with autocomplete, because it is kind of a strictly a very temporal state to the component or the search field that you are searching on. There's some really good examples, but it's really just you detect, when changes happen on the input, you switch map and then call your service. But you could certainly expand upon that if you needed to. Let me see here. Good questions. Does anybody have any other questions? Yeah, so the one question is it possible to get the sample WebStorm project? And absolutely. So if you go to github.com, One Hungry Mind. And so one of the things is also, I just want to kind of set some expectations, is that this took me probably 2 or 3 weeks, I want to say, to kind of change my thinking into this Redux, state down, events up, kind of a thing. So poor Rob Wormald is that I spent a lot of time bugging him about how to do this. And so within an hour, I have no illusions that, no matter how good of a teacher I am, how good the material is, that this is a pretty kind of a new and possibly complex topic. And so what I would love for everyone to do is, if this was interesting and you kind of see the value of like, hey, we need a better way to manage state and control flow and code volume, then we should really take a look at NgRX and see what it's about. Pull down the code here, so you can pull it down. It's completely open source. Everybody can have it and check it out. And that's I think where things are really starting to um, kind of come together. So when you start to actually play around with code. So the question is, how would you recommend to store relational data in Redux, like categories that have products? And so this goes back to the reactive data piece that I was talking about. You can do it 2 ways. So one, using observable combined latest, but what I would probably do now is simply use reselect. And what that allows you to do is essentially take relational data, and even though they're separate, is that create a selector that combines them. So let me see if I can find one of these in here. Here it is. So in this case, what I'm doing is I need to get stock history, and I need to get essentially combine stocks and the selected symbol. And what I'm doing here is I've created this selector called get stock history that I'm passing in two other selectors, and then as a third category or a third parameter, then I'm passing in this function that says, okay, I'm taking all my stocks and I'm taking the selected symbol, and I'm going to essentially create this new thing that I can then bind to. And let's see where we're actually using this. Right, so what component is this? So yeah, and the stock component is we're actually getting stock history. So this is very much like everything else, is that store.select, but we're saying select stock history from the store, which is essentially looking for this selector here. So now we're basically saying we're able to create these really small kind of, think of it as like almost like SQL queries or like database queries of like, okay, go get this and take these two things, combine them, and now return this new thing. And so to answer your question, really quite simple, is to use reselect for this. Although I possibly would use observable.combine latest given um, the uh, given kind of the needs of this. So the next question is, what if such data will be loaded upon request? So for instance, you're routing and then fetching. Um, the selector is essentially recomputed every time something changes, which is good. I mean, so this is kind of the nature of reactive, is that, let's say, categories and products, and let's say the categories change, or more specifically, the products change, that we want to know about the newest version of this. And so using reselect or combine latest, when one of the entities within the computed data changes, then it will go ahead and recalculate that or recompute that. Not before, but when it happens, it'll change and then push that new data out to you and make it available. And so that is, again, let me point this out, is that, let's say, in this case, selected symbol. So somebody selected a new symbol. What's going to happen is it's going to detect that. It's going to recompute stock history, which then goes into our stocks component. And because this is an observable, that this gets routed out or basically streamed right into our template and passed out. So stock history, async, and it just streams right down into this component. I'm not for sure why this is clicking through to the spec, but, and then within our component, you'll see here, is this is just a kind of I don't think we're supposed to call them smart and dumb components anymore, but this is a really kind of a dumb stateless component in that it's not doing anything. In the history component, it's just taking this history input and streaming it. And so to me, like, this is really, really neat, is that we're just streaming this into our component and rendering it. And how we're getting it is just by pulling it off of our store using this selector, and it's going through. So our ability to get this is just a couple lines of code. And what you'll notice here is that if we go to stocks, so this is kind of what we just saw, that when I select a stock symbol, is that it's just recomputing the selector, and it's automatically essentially generating new stock history that we're binding to because it's an observable stream. It's being piped into our template. So how would you recommend to store similar kind of data sets, like having multiple grids with different set of filters? So what I would probably do is create a selector that basically represents kind of the variation. So if you had like 10 variations of how you wanted to see your data, is I would just use a selector or create a selector for that. I mean, so this depends on how you're doing that. Is, do you just do a filter on the template, like a custom filter or a pipe rather? That may be acceptable, or you could do it with a selector as well. So I think that's kind of, without knowing any more details, is if the data is the same, then I would just determine, do I want this to be available on an application level? In that case, I would do a selector, or if it's only constrained to this particular container component, then I may just do a custom pipe and then just kind of switch off from the data there. So it might, you're not really mutating the data, you're just kind of filtering it out. So that is, I mean, that's kind of, I guess, the question you would have to kind of think about and dig into is, what is the scope of kind of this filtered data? Is it application wide? I'd probably do a selector. If not, I probably would just do a custom pipe, or even one that's built in if possible. I think if anybody has, maybe let's just take one or two more questions And Audrey, thank you for hanging out. I had a lot of fun. But I maybe have one or two more questions if anybody has anything they want to ask. Just kind of to reiterate, I talk a lot about this on my blog. So Observables, I talk a lot about NgRX, and as well is if you want to see the sample application, you can check it out here. And that is, I think, everything that I've covered. And I will as well, if enough people ask, I'll just coordinate with Luxosoft. DevTools. Okay, thank you. All right. Well, I think I just made a new friend here. All right. So this is one thing I haven't talked about. It's pretty easy to hook up, and this is pretty amazing. Let me just close this all down. If we go into App Module, so one other thing is I just upgraded this to Angular 4, so I need to fix some of the test as well as the way material is consumed a little bit different. So there'll be a couple tweaks in the next couple of days. But what's awesome is you have this store DevTools module that you can instrument with extension. And so what that means is that I've installed the Redux extension. And if you go here, that we refresh the page. Hold on. Sometimes this doesn't take. There we go. Is now you can see that as we start to make changes, so we'll go over here. Let's go to portfolios. As you can see that as you start to step through your application, that you can start to see what is happening. So in this case, I'll select portfolio ID here. You can do all sorts of interesting things. You can see like the action. You can see the state. So you can actually see the entire state of your application. You can do it as a chart. And so I can drag this out here a little bit more. I mean, this is just a really kind of a crazy thing that so when you see here, let me just scroll this down. And this is, I mean, I almost should have just showed this first, is that, remember when I said you had a single state tree, that you can actually visualize this entire thing in one spot. And so you can see, your actions. You can see it, the raw action that we're dispatching. You can kind of see the different sequences that has happened and kind of see what's happening in your application. So really super easy. I just installed the DevTools, and then you just hook it right into your application using this store DevTools. And let me show you. So if we go to GitHub.com, NgRX, it is right here. So they talk about the DevTools, and it just shows you how to install this. But DevTools are amazing, super amazing, and it allows you to essentially see kind of your entire state as you are working through the application. So you can see here, it's like, for instance, I'm setting and I'm filtering this out. You can kind of see how this is happening. And so there's just so many things you can do with the DevTools, and it takes like 3 minutes to set up. So, being able to look and say, like, this is everything that's happened in my application, all of the state is, you can see portfolio load success, stock load success, whatever. So these are even in the actions. If you go over here, that you'll notice that I'm giving these kind of some interesting names, or rather descriptive names, so as they fly through, that I can see, okay, select, load success, and so on. So this is really, to me, like icing on the cake. If you need to step through and you're like, why is my application doing this? DevTools is how to do that. So thanks, Andre. Really good suggestion. I totally had that, and I must have just forgotten about that. So again, I'd like to just, I think as we wrap up here, just thank Luxosoft for making this just a really fantastic webinar, and allowing me to share this time with you. And I think that when a company makes these kind of resources available, I think it shows really that, we understand that, when the community wins, when a developer wins, every one of us wins. And so thank you for this opportunity. And it's been really fantastic, and appreciate all the good questions, especially from Andre. High five. Psh. And with that, I thank you so much. And that's all I have. So I don't know if the moderator.
I'm here, Lucas. Yeah, thank you. Thank you for your fantastic presentation and for all your answers. Guys, thank you for being with us tonight. And now you see this short questionnaire. Please be so kind to answer a few questions. We will appreciate your feedback. And one more time, thanks a lot. Stay tuned for our further events and good night. Thank you, guys.